Hi everyone, welcome back. In this video, we'll be talking about strong versus weak acids. So for acids, we will talk about a very famous chemist whose name is Arrhenius. So the traditional Arrhenius theory says if a compound that ionizes producing hydrogen ion plus something else in water, then it will be considered as as an acid. So this is a traditional model. But sometimes we will find that this traditional model does not explain certain scenarios that is factually true, such as when there's a distinction between strong acids and weak acids, and also how to explain that some compounds like carbon dioxide that's not necessarily ionizing water, but it is indeed acidic. So we will look at a modified Arrhenius theory, or sometimes we call it hydrolysis. So if we look at the word hydrolysis, we will see hydro in the beginning. So it's essentially analysis applied on the reaction with water. So for example, if we want to identify whether hydroiodic acid is a strong acid or a weak acid, we can use a hydrolysis equation. So hydroiodic acid will react with water, produce hydronium ion. So this is the key distinction between a traditional Arrhenius theory and a modified Arrhenius theory or hydrolysis reaction. So if it's a hydronium, that means we're offering one more hydrogen atom or a hydrogen ion to water. So the hydroiodic acid or hydrogen iodide will lose one oxygen ion, becoming simply the iodide ion. And if we look at this, sometimes it will tell us that this hydroiodic acid is actually a strong acid. And the definition of a strong acid is that when strong acid ionizes or dissolves in water, all of its compounds will be ionized into hydronium and the respective conjugate base. If we look at one other example, for example, acetic acid or vinegar, then we will actually see that when CO3COOH is reacting with water, we will still expecting a hydronium on the right side because vinegar is an acid and one of the H will be given to the water, so it will become CH3COO minus aqueous. And in this process, we will actually notice that instead of a straight arrow, we will use a double-sided arrow and less than 50%. So this is to say that when acetic acid ionizes in water, only less than half of its original compounds will ionize into hydronium and the respective conjugate base. Therefore, it will be considered as a weak acid. Now, we will try to use a hydrolysis equation to explain why carbon dioxide, for instance, is a acid. So there are generally two steps associated with this. The first step is that carbon dioxide will react with water to produce hydrogen carbonate. And then with this hydrogen carbonate, it will actually react with water again, which is the actual hydrolysis equation. But this time, since it's a weak acid, we'll use this and we'll produce hydronium ion and the respective conjugate base formula, which is the hydrogen carbonate ion. So with these two steps, we can actually prove with hydrolysis equation that carbon dioxide, even as a gas, when it's dissolved in water, it will still be acidic. Surprising. So these are the three types of strong or weak or non-metal oxides that can be used with hydrolysis equation to finalize their identity. Thank you for watching.